Hi, this is going to be a super fast video, Mat120 intermediate, what? Algebra. All right, so this should be a little bit faster than normal. We're going to talk about functions, and I remember we didn't have function notation, or we didn't learn it until we got into college, so you're having a real advantage. Okay, first we want to talk about one-to-one correspondence. If a problem has or a one-to-one correspondence, then we call it a function. Okay, so here we have a problem, and what it is I just like to think of it as shooting arrows. In each guy, these are x's. By the way, the x's are called the domain, and these are the y's, and the y's are called the range. I just thought of that. Might be important. So any number or whatever's in this domain is only allowed one arrow to shoot, and it can only shoot at one target. Okay, it can shoot at the same target another guy shoots at, but it can only shoot one arrow. That's the key. So this is called a function because each one is shooting one arrow. It doesn't matter if they cross paths. It could even look like this. Let me show you another one. 4, 5, 6. Let's suppose this guy shot at this one, and this one also shot at him, and this one shot at 6, and nobody shot at 5. That's okay. That's still a function because they're only shooting one arrow. That's good. So that's fine. Now in this one, you can see that 1 is shooting at 6, 2 is shooting at 5, 3 is shooting at 4, but it's also shooting at 6. It cheated, it grabbed an extra arrow, and therefore it's not a function. Not a function. So we would call this is a relation. We can call it a relation, but there's too many arrows shot in the domain. Number 3 is a little cheater. Okay, this right here was a function. Okay, so these start out as relations, but a certain kind of relation is called a function. We can also observe it by a graph itself. If we can only go through the line one time, and you're probably familiar with this, with a vertical line and it crosses the graph at only one point, then it's a function. So this is a function. No matter where we draw the line, it only hits the graph one time. One time, one time, one time. Now, in this one, we can see this is not a function because it goes through it too many times. It hits it once, it hits it again, twice again. So it's called the vertical line test. And you probably have used this before on quizzes, probably in the 8th grade or whatever. Okay, another thing we can do with functions is graph them. This is read f of x, or f at x, but usually we say f of x equals 1/2 x plus 3. Well, it sounds really confusing, but f of x means the same thing as y. It's just another way of saying y. It's a little bit more detailed because by using this, let me show you a little something. If I use this notation, f of x, I shouldn't have erased it out. I can put numbers in here. And of course, since we have a fraction here at 2, I'm going to use multiples of 2 because I want to graph this. So I could put a -2 in here. I can put a 0 in here. I could put a 2 in here. And what this is telling me is these are my x values or my domain. These are the values I'm using for x. And I'm going to put these into this little like a machine. 1/2 times -2 gives me -1 plus 3 is a -2. This is my input, x, This tells me the numbers I put in, and this is my output, y. Output. So it's like a little machine. It's kind of cool, huh? I put in a number, I get something out. In this case, I got the same number, huh? I put a 2 in here, was double checking -1 plus 3. Okay, now I'm going to put a 0 in here for x. And as an output, what am I going to get? That's right, 3. Input, 2, half of 2, 1, 1 plus 3, 4. Sounds a little off. 1 plus 3 is 4. This one looks like it's off. See what I did wrong? Because I'm looking here and I don't have a pattern. See, I should have a pattern. There's no pattern. So let's go back and check because these are kind of in a pattern. This was -1 plus 3 is a +2. You see, that way I can catch, I did that on purpose, so I can catch my mistake. Did you catch my mistake when I did it? You were probably yelling at Mr. Mitchell, it's wrong, it's wrong. Thank you. Okay, so let's graph these. Don't have much room, but I think I can do it. What is this axis? X, Y. This is your domain. This is your range. Okay. Just another way of looking at them. So, another bunch of words, huh? -2, 2. 0, 3. 2, see, this is my x value. It's standing for the point 2, 4. This is my x. This is my y. 2, over here, 2, 4. 1, 2, 3, 4. There we go. Beautiful little graph. Kind of coming down through here. Try to hit it just right. There we go. You know what I'm going to call this picture? I'm going to call it y equals 1/2 x plus 3. That's the name of this graph. Every graph has a particular name. That's the name of that graph. All right. Last one, we're going to evaluate these functions. So what do you think this one means? This one means replace this s right here with a 1. Put a 1. So wherever we see an s, we're going to put the number 1. This is 3 times 1 plus 4. Well, that looks like 7. 2/3. Oh, God. 3 times 2/3 plus 4. 3 times 2 is 6. 6 divided by 3 is 2. See, it's just multiply and divide. 6 divided by 3 is 2. Or you can cancel off the 3's. 2 plus 4 is 6. These aren't picked in any particular order. Now I'm going to put in something really strange, an a minus 2. So I'm going to put an a minus 2. That's why I want to use parentheses. Notice when I sub, I put parentheses plus 4. So underneath here, I'm going to distribute that. That would be 3a minus 6, right? Plus 4. But I want to simplify that. I don't want to leave it like that. So that's 3a minus 2. So there's my answer. When I put in an a minus 2 into this problem, into the original problem, I'm replacing the s with the whole expression. I can put a whole thing in there. But I want to distribute to both terms. Remember, we're distributing to both of those terms. Okay, how about this next one? Kind of weird. H of x equals 19. When I put a 1 in here, what do I get? I get 19. When I put a 2/3 in here, what do I get? 2/3 equals 19. When I put an a minus 2, doesn't matter what I put in here, it's saying you always get a 19. So we could have one like that. That's a little bit on the weird side. Now, sometimes we have a more complicated. So here's one with powers, 2x squared minus 3x. Let me write that on the back on another sheet of paper so you can see it a little bit. Grab a piece of paper. Maybe I'll grab a piece of paper. So maybe I'm writing a little small. Function of x equals 2x squared minus 3x. So first time I'm going to put in a 0. Okay, 2 times 0 squared minus 3 times 0. So all the x's become zeros. Kind of a neat way. It's telling me what to put in here instead of writing directions. So I get x equals 0, substitute in, you know, instead of all that, see in math, we try to be very concise. So this is saying put a 0 in place of all the x's if it was function of x. And this could be g of x. It doesn't have to be like we had here. G is g of s. It could be anything. But replace all these variables with zeros. Okay, 0 squared, 0 times 2, 0. Minus 3 times 0, 0 equals 0. So when I put it in, it came out to be 0. Now I'm going to put it at 2. 2 times 2 squared minus 3 times 2. 2 squared, 4. 4 times 2, 8. Minus 2 times 3, 6. Power, then multiply. Don't multiply first 4 and then do the power. 4 squared is 16. I've got kids in calculus that are making these mistakes. Okay, power first, then multiply. This is the first thing you do. Of course, that comes out to be 2. All right, let's try another one. Function of negative 5. I'm going to put a negative 5 in here and square it. Minus 3 times a negative 5. Negative 5, again, don't multiply. Raise it to the power. Negative 5 times negative 5, positive 25. So this is 25 times 2. 2 quarters, 50 cents. Negative times negative, positive. If you want to do chick, you could. Chick, if it's helpful and it helps you. Negative, positive 15. Negative times negative, 65. So you just want to be careful. Don't do them so fast that you make a mistake. A negative times a negative is a positive times positive is positive. A negative times a negative is a positive. Okay? Hope you enjoyed the video. That's all we're doing today. It's kind of a quick one.